So, hello everyone again. This is lecture 3 part 3 of wave optics. Today we will go with the further discussions of Doppler effect only. In the last lecture I explained to you two different examples of Doppler effect. First of all using the wavefront concept, and second using a real life example of how the pitch of the sound heard by our ears of the sound horns coming by the cars is being heard with the change in the time. The change in the time refers to the source coming near the observer. The second, the source at the instant position, we are talking about when the source is stationary, let us suppose, and the third was when the source is moving away from the observer. So, let us move on with our further discussion on Doppler effect only. So, the complete definition of Doppler effect was being understood in the last lecture only. Let us move on with this discussion today. So, now for velocities small, that is compared to the speed of light. So, let us suppose the velocities are very less than c. C is nothing but speed of light. Just to iterate to you, what is speed of light? It is approximately equal to 3 into 10 to the power 8 meter per second. So, for velocity is very small compared to the speed of light, we can use the same formula which we use for sound waves. So, what is the formula? I will try to explain to you. So, the fractional change in the frequency, fractional change as in change in the value of frequency, that is delta nu per unit change, that is by dividing by delta dividing by nu only. So, the fractional change in the frequency, that is known as delta nu by nu, is given by minus v radial by c. What is v radial here? V radial is nothing but the component of the source velocity along the line joining the observer to the source relative to the observer. So, if we are assuming that the velocity of the observer is 0, then this time the velocity radial will be v radial will be equal to v radial minus 0 only. What is v radial? V radial is nothing but the component. So, there are basically two components, one is radial, that is going towards the source, and one is tangential. So, we are not talking about the tangential here, we are only talking about the velocity that is happening, or that is moving towards the observer. Because the observer is being assumed as so stationary here, and only the source is being moving, that is where the relative velocity is again the second part, that is anytime when we try to find out the value of relative velocity, let us say v dash, that is nothing but v 2 minus v 1, but because the velocity of v 1, that is this time observer is 0, hence v dash, that is relative velocity, is nothing but v 2 only. So, that is only the concept being talked about in this point here. So, v radial is the component of the source velocity along the line joining the observer to the source relative to the observer. Relative to the observer is at the velocity of 0. V radial is considered positive when the source moves away from the observer. So, this is just the sign convention. The sign convention which we are implementing is, we are assuming that when the source moves away from the observer, when the source, let this be the observer, let this be the source, then when the source is moving away from the observer, then we are assuming that the velocity of v radial will be positive. Similarly, if the source will be moving towards the observer, we will be assuming that the velocity of what we can say velocity will be negative. Same thing can be also observed from this diagram. So, now when I was trying to explain to you the concept of change in the frequency, either increasing the frequency or decreasing frequency, let us suppose that the observer is constant and the source is trying to go away. So, when the source was trying to go away, the frequency bands or the wavefront bands were increasing apart. So, this time the frequency will be decreasing. So, when the v radial by c is positive, you can see that the velocity of delta nu by nu will be negative. Quite evident, the frequency will try to reduce, and hence the amount of time required will be more. Similarly, when we are trying to assume that the velocity of v radial, when it is moving towards the source, towards the source will be negative. So, negative gives positive value, hence when we are trying to do, the frequency is increasing, quite evident that delta nu by nu is positive. So, hence our complete theoretical part is also evident or quite clear with the what we can say formula part here. So, thus the Doppler shift can be expressed as delta nu by nu, that is the fractional change in frequency is nothing but equal to minus v radial upon c. What is c here? C is the speed of light. So, the formula given above, just to take it here, the formula given above is valid only when the speed of source is small compared to that of light. That is what he is trying to say is, this velocity of v, either v radial or v, is very less than c. Only then and then only this formula is applicable. So, this thing is also done, the formula, because almost when the sound waves are being considered, the velocity is nothing but around 330 meter per second, 350 meter per second and so on, and when light is being compared, it is 3 into 10 to the power 8 meter per second, quite large difference is there. So, the formula given above is valid only when the speed of the source is small compared to that of light. A more accurate formula for the Doppler effect, which is valid even when the speeds are close to that of light, requires the use of Einstein's special theory of relativity. So, this concept is being not applicable or not being required for right now in your 12th class chapter, but when you study further, a small change in this will lead to applicability of this formula even when the velocity of the v radial we are talking about here is being always similar, or is in the ranges of 10 to the power 6, 10 to the power 7 or even 10 to the power 8. So, just to explain to you that even this formula of Doppler effect is applicable for ranges of velocity similar to speed of light only, but that also requires Einstein's special theory of relativity, some major changes. I will not go into that changes right now, just to explain to you I wrote this line. So, now the Doppler effect for light is very important in astronomy, quite evident, and that is why how we try to explain the concepts of red shift and blue shift, which we studied in the last part only. So, it is the basis for the measurement of the radial velocity of distant galaxies. So, one of the application, if I try to explain to you, so let us suppose what the astronomers do is they try to explain, they try to see if the galaxies or if the planets are moving away or towards you. So, what does they try to view is they try to view the applicability if we can see a red light or a blue light. So, depending upon the applicability of red light or blue light, you can understand that the planets are going away from us or towards us. So, this is one of the application of Doppler effect. So, this was the complete explanation of the Doppler effect. So, let me explain to you the same application using one of the example. This is the same example as NCERT book only. So, please look over here carefully. So, what speed should a galaxy move with respect to us, so that a sodium line is nothing but the wavelength, this is the wavelength given to you for the sodium line here. So, that the sodium line at 589 nanometers, nanometer is, just to explain to you, 1 nanometer is 10 to the power minus 9 meters. So, sodium line at 589 nanometers is observed at 589.6 nanometers. So, what is trying to make us ki there will be a decrease, there will be a change in the position of the galaxies when we are viewing it from the earth. So, this time our earth is the observer and that planet is the source. So, if we will try to move away, then there will be a change in the wavelength, as we tried to understand from the first lecture slide of Doppler effect, that either there can be a red shift or there can be a blue shift. So, depending on that change in color, there can be a change in the wavelength. If there is an, so as you can see, there is an increase in the wavelength here. If there is an increase in the wavelength, I will just explain to you from the that line only. So, when there was an increase in the wavelength, there was a red shift. So, what is, how it is applicable to astronomers? So, when they try to view that planet or galaxy from a telescope or a very ultra high telescope, if you view it quickly, if you view it very clearly, then if there is a red color being seen, then it was observed that there is an increase in wavelength. How the wavelengths are being captured, how the wavelengths are being calculated is not our part of discussion right now, but they have special instruments from which they can calculate the wavelength at different time frames. So, at time t is equal to t1 they have calculated 589 nanometers, and then some at time t is equal to t2 they have calculated as 589.6 nanometers. For us, what we need to calculate is the wavelength increasing, and if the wavelength is increasing and when they are viewing it from their eyes, if they see a red color shift, then they understand that the increase, there is an increase in the wavelength. So, just to iterate to you again, so now there was an increase in the wavelength from 589 to 589.6 nanometers, and they are trying to understand that what should be the speed with which the galaxy is moving away with respect to us. So, they need to find out the relative velocity only. So, relative velocity is nothing but the velocity of v radial here. So, this is the simple concept we know, that v dot lambda is equal to c. This is the same concept you also studied in your ray optics chapter. So, now delta nu by nu is nothing but minus delta by lambda for small changes in nu and lambda. Also, what we know is, just to use the equation from below, that is delta nu by nu is nothing but equal to minus v radial by c, which is equal to minus delta lambda by lambda. Hence, if I try to calculate the value of v radial, only from this diagram right here. So, this minus signs get cancelled, and therefore, this is nothing but plus C multiplied by delta lambda upon lambda. So, C value you know, delta lambda is nothing but 589.6 minus 589, that is nothing but 0.6, and delta lambda is the initial position. Please make sure that when the use of delta lambda is being asked, the lambda will be the initial position only. So, here just to iterate to you, just to write everything clearly, so that everything is visible. So, what I did was, this was the mathematical formulation I did. First of all, delta nu by nu is nothing but delta lambda by lambda. Let this be the equation number 1. Then from Doppler effect, we understood the concept that delta nu by nu is nothing but V radial by C. Please make sure that the V radial is in itself is the relative velocity of the source with respect to the observer, and that is only asked here. Now, using equation 1 and 2, what we get is delta lambda, sorry, this will be minus here. So, minus delta by lambda is nothing but minus V radial by C. Now, if I try to remove this negative sign, and if I try to find out the velocity of V radial that is required, is nothing but plus positive C multiplied by delta lambda by lambda. So, here the value of C will be 3 into 10 to the power 8 meter per second, delta lambda will be nothing but 0.6, and delta and lambda will be lambda initial, that is 589. So, when you try to calculate this completely, you will get the velocity of V radial as 306 kilometer per second. Therefore, the galaxy is moving away from us. So, as we already did the sign convention, that if the V radial value is positive, it is going away from the observer, and if it is coming negative, then it is going means if it is positive, then it is moving away from us, and if it is negative, it is moving towards us. So, this is the complete concept of application of Doppler effect, and how we try to, how the astronomers use it for their application. So, this is the complete end of the first 3 points. In the first point, we started with the introduction chapter, about the wave optics, the differentiation of wave optics with the ray optics, differentiation of wave theory of propagation with the Descartes theory, that is corpuscular theory of light, then the application, the more research part about Thomas Young, etc. Then the second point, we studied the Huon's principle, wavefront concept, and so on. In the third point, we studied about the refraction laws, reflection laws, application, behavior of prisms, thin prisms, convex lenses, concave mirrors, etc. and then a little bit about Doppler effect. Now, I will introduce to you a new concept of coherent and incoherent addition of waves. Please look over here carefully. It is a very interesting concept, but a little tedious one. So, just try to understand everything. So, first of all, do not go over the complete theory part. First of all, let me try to explain you what is the figure towards your right. So, what is happening here is, these are the two needles. I will try to go very slowly on this part here. So, these are the needles now, and this is water, calm pool. Just let me write here, it is nothing but calm pool of water. So, now what will be happening here is, what is the complete procedure we will go on when I will try to explain it from the left hand side, but for now what is happening is a similar case. Let this be the needle and let this be the wave, let this be the virtual pool I am talking about. So, what will be happening is, when I try to dip into this pool, again the point at which the needle is being in common or is in with intersection with the pool of water, that will be the primary source of disturbance, and then at some time t is equal to T1, T2 and so on, there will be circular ripples being formed. These circular ripples are nothing but the wave fronts. At some time t is equal to T1, then T2, then T3 and so on. Similarly, what will happen is, if I use two pools, let us suppose that these both have the same scale, these both are pens only, these both are needles only. If I try to put both of them into the needle, what will happen is, we will find out two different ripples being formed. So, some of the, like, just to explain to you, this is a little detailed diagram of what is happening is, it is a little hodgepodge, two things are being explained in a similar diagram. I will try to explain to you, but for now just try to explain it. Let these be the two needles. When I try to put it downwards, then the circular ripples will be formed. So, this is nothing but the explanation of the right hand side figure. Now, let me explain to you whatever is written towards the left. So, please look over here carefully now. This is a new concept, so try to understand it very nicely. So, the entire field of interference is based on the superposition principle, according to which a particular point in the medium, at a particular point in the medium, the resultant displacement produced by a number of waves is the vector sum of displacements produced by each of these waves. So, little bit long line, but nothing, it is nothing but the just the simple point of what is superposition. What is superposition? It is superposition is nothing but the addition of two different things, and this is not a simple addition, it is a vector addition. How is vector addition done? Let us say if I try to superpose A vector and B vector with a C vector, then this superposition is nothing but A bar plus B bar. How is this being done? Why it is being done? What is the necessity of doing an interference? What is the necessity of doing an interference? Superposition, etc. will be dealt in the subsequent slides. For now, just try to understand this concept that interference is nothing but based on superposition principle. And what is superposition principle? It is nothing but the vector sum of two different displacements happening at two different points. So, let us move on to the next line again now. So, it was nothing but just to let me highlight this. So, it is the resultant displacement produced by a number of waves is the vector sum of the displacement produced by each of those waves. So, one wave can be understood as S1 thing and one wave can be understood as S2 thing. So, let us move on. So, consider two needles S1 and S2 moving periodically up and down in an identical fashion in a trough of water. So, trough of water is nothing but the calm pool of water being talked about here. And what does this line mean? Moving periodically up and down in an identical fashion. Periodically, as the name suggests, is at, let us say, at time t is equal to 0, at time t is equal to 2, at some time t is equal to 4. This is the duration of S1. So, at time t is equal to 0, there was no needle. Let us say I write no needle as no, and if when the needle is being dropped into the calm pool of water, I write it as yes. So, yes, no, yes, and let us say for needle 2 it is t is equal to 0, then at 3 and then at 6, let this be 2. So, what is periodic motion? Periodic motion is nothing but if the time difference between the two portions or two different methodology being happened is same, then it is known as periodic motion. So, what is the procedure happening here is, so for S1 what is happening is at t is equal to 0 it is above, at t is equal to 0 it is above, then it is going down, at t is equal to 2 it is coming above again, it is going down, it is coming above again. Either the thing which is happening for needle 2 can be same, that is at t is equal to 0 it is here, 2 second it is coming down, 4 it is coming up, or it can vary also, that is at t is equal to 0 it is here only, at 3 it is going down, at 6 it is going up. So, the point to be considered in understanding the second point is that there are two needles and they both are periodic. The period cannot be same, may not be same, but it can be same also. So, that is only the thing being talked about here. So, either it can be like this or it can be like this, or something like happening here, then it is going, it is coming above, it is going. Just the point is the period is always same, it can be either same, either different. What will be the consequences of having the same? What will be the consequences of having it different? What will be the consequences and applications of these points? This complete concept, and we will try to understand it when we will try to understand this figure. What is happening is, what are these dashed lines? If you see clearly, what are these complete dark circles? This is nothing but the application of, or this is nothing but the explanation of how coherent and incoherent addition of waves is happening. As from the name also you can suggest, there is some addition of waves only. How can there be an addition of waves? There can be addition of waves if there are multiple sources, either there can be 2 sources, 5 sources, 10 sources and so on. What is coherent, what is incoherent, we will try to understand, but there can be the if you try to understand from the figure name only, then something from this period distribution, something from this period disturbances is related to this coherent and incoherent addition of waves. For now, I will try to conclude the chapter here only. So, what we understood from this concept is, we tried to understand the concept of formula of Doppler effect first of all, then we tried to explain, I tried to explain to you one of the explanation of Doppler effects example, and finally, some of the brief of what is the figure on the right hand side and what does this periodically up and down movement means. For now, I will try to conclude this here only. So, the course progress for you. So, in the first 3 lectures we have completed with the introduction part, Huygens principle part, that is definition of wavefront and how, if at time t is equal to tau, if we need to calculate the wavefront, given that we know the wavefront at t is equal to 0 is being talked about. Then in the third part we got to know about the refraction and the reflection part, that is how the refraction laws and reflection laws can be understood by the concept of wave theory or wave propagation of light. In this only we understood a small concept of Doppler effect, how the Doppler effect is being formed. Doppler effect is nothing but the change in the frequency with respect to the relative position change in the source and the observer. Either if we try to explain the same concept using sound waves, there will be an increase in the frequency or decrease in the frequency. And finally, after this explanation, we are now in the fourth part, that is coherent and incoherent addition of waves. We will go with the further discussion in the next lecture. For now, this is the complete concept here only. And so, thank you.